Hi, my name is Austin Wells. I'm currently working as an aerospace quality machinist. I do quality inspection on parts that get used in all sorts of precision equipment, including things that go all the way to space. I have a long background in customer service, mostly in the tech industry. I did a lot with networking, voice over IP, Microsoft Exchange, and the purpose of this video is to introduce you guys to a project that I call Homebase, which is a library framework of sorts for running LED large pixel displays, like those seen on sites like Adafruit and SparkFun. The purpose of this was to kind of take out a lot of the hard work that goes into setting up those projects. And joining me today is my dad, Larry. If you want to go ahead and introduce yourself and kind of explain your background as well.
Hi, I'm Larry. My last endeavor was as a physics and chemistry teacher at a high school out in nowhere, Indiana. Prior to that, I worked for IBM as a punch card repairman, and after that, electronics technician for a company that made a oil detection unit. And from there, I taught technical school for 11 years. And from there, I worked in the area of automotive electronics, primarily testing automatic brake control systems. And from there, that's how I got involved into microprocessing and C code. And from there, I worked on radio systems with their software, worked on software that involved battery components that went into automotive. Somehow I couldn't escape from automotive. Spent a short time in a company that worked on a defibrillator that was had some had some features that were better than others. A startup company out in California did testing on that, and once I left that place, sure enough, I got back to automotive and put in the radio systems, or as they call infotainment, if you know the word, in Cadillacs. From
Nice.
Cadillacs, that's when I got back into teaching school, and from there, setting up a robotics uh, coaching position out in, again, nowhere, Indiana.
Awesome. So yeah, basically we're gonna be reviewing this project, kind of taking a look at the functionality of it, sort of the goal of what it's designed to be, how you can use it, as well as sort of how you can expand on it and use it for your own projects. So to get things started, if you want to download this project yourself, this is going to be a link in the description as well as a card in the corner. You can go ahead and pick this up at my page, github.com/otacon239/homebase. And here you'll find the README that we're going to be going over to start with on this video. And
You want to
this'll explain a lot
give
of
that,
this.
you might want to make sure they know that GitHub identifier. Give
Yes.
it one more time because it's easy to slip by that.
Yep, that's going to be Otacon239, OTACON. Any fans of the Metal Gear Solid series will know that name very well. But yeah, so let's go ahead and we're just going to review the README because a lot of the information is here. But there's still certainly plenty to talk about as far as how this project can be used. So, yeah, just
Do you
kind of.
want to explain what the scrolling image is above the screen?
Yes. So what you're seeing at the top, this is what the project displays. So this is what you're seeing is a virtual representation of Homebase. This is running locally on this computer and being sent over the network to a remote display. So that is essentially the core of this project. It's a way to design LED display projects without the hassle of building it from scratch every single time, which I found myself doing on multiple projects. The other element of this that's quite a bit different than a lot of others is that we're using processing for this. We're running this at a software level instead of trying to run it on the bare metal hardware such as an Arduino or an ESP32. We're taking out that aspect of the project and we're simply sending that information remotely to another display, which we'll get into detail later about how that all works. But the important thing is what you're seeing at the top is the an example of how this project can be used to build your own display from scratch.
So in place of this virtual display, you'd have a physical panel that had all these LEDs in there, and you could put it up on the wall,
Mm-hmm.
so it kind of represents a sign or anything else somebody might want to use.
Exactly. And in fact, I'm going to throw in the corner of the screen here right now an example of what that might look like. I'm also going to show a couple of examples here of some other code that I've written using the same concepts as this project. It's not, so there's sort of two elements to this that make up what this project is. The first element is the graphics portion, what you're seeing here. The second element is the UDP, the ability to send this signal over UDP to the remote display. So what you're seeing here is the code, the main chunk of code that we're using to make this possible. And then I've, again, just shown a couple other examples of sending a signal over UDP using this same concept.
And
Processing
what's
makes
can you expand on UDP real quickly for those that don't know what UDP means?
Yes. So UDP, I'm trying to remember the acronym, which I'm not remembering off the top of my head.
Universal Data Packet.
Oh, making me look bad. So yeah, it's Universal Data Packet. It's in comparison to TCP, which we won't get into. But the long story short is, it's a it's a network signal. So you can either plugged in wired or wireless. You're essentially sending a signal between two devices, or at the very least, sending a signal over a network so that one program can send information and do all the hard work of generating that information. And then another program receives that information and processes it in its own way. So it's essentially a wire between two virtual applications.
Great.
So one of the core concepts of this project is that I'm avoiding the effort of building a program for a piece of hardware one time and then going to another piece of hardware that's not built on the same library. Like, let's say you're switching from an Arduino to an ESP32. If you wanted to make this same display, you'd have to completely rewrite large portions of the program, if not all of it, if you're switching languages. And I found that incredibly frustrating when trying to make simple little testing projects or art projects or miniature displays. And I simply wanted to eliminate all of that extra overhead. So instead, we're running this program on a software package known as processing. It's a bit of a heavier application. It requires Java, so you need a full operating system to run it. It also requires a display to be attached, which we'll get into a bit more detail about why that's a limitation. But it does require a physical display to be attached beyond the pixel display that you're trying to drive. And so this is, for lack of a better term, hardware agnostic. This takes the software project, you build it once, And then now you can go to any piece of hardware, and as long as you can write a receiver that that absorbs that UDP packet and displays it, all of your graphics work is already done for you. You don't
What
have
was
to
the
go through and recreate that.
what was the original market for processing?
The original market was for artists. If you take something like Python or C++ and you want to write pixels to your display, like just on your computer screen, and you just want to have a little window where you draw a square and that square bounces around and moves in a certain way, you usually have to write several dozens of lines of code to establish your workspace, to draw your window, to draw your canvas, to tell it what a square is, to define point to point to point. I want each of these pixels to be enabled. It is tons of code overhead. So what processing does is it just starts off assuming you want to work with a graphics library. So your canvas is there. Your pixels are, just pixels. You don't have to explain anything to the computer about the space that you're working in. That's been done for you. So when you want to draw a square, you just ask for the square function, or in this case, the rectangle function. If you want to draw a circle, you call the circle function. You don't have to define what a circle is and do all of the hard work of math and offsets and all of this extra work, when that can be incredibly tedious for somebody who just wants to draw things to a screen, hence this project. When you just want to have text appear on a canvas, you don't want to have to spend a week doing that. You want to see results now. And that's the ultimate point of processing, is to take that middleman and get rid of it.
Okay, processing encapsulated.
Yeah. So with that all being said, I kind of took it a step further. There were a bunch of things that, again, between different display projects that I've written, I realized I was doing multiple times over and just wanted a quick way to iterate on those ideas. So I built a project that has a bunch of those functions built in. For instance, here we've got simple color control of each of your line objects. You've got the ability to have the text scroll across the display like you're seeing here. Very simple date and time formatting so that you don't have to, figure out a bunch of, how am I going to set up this string and how am I going to prepare that. I've got a weather API built into here with Open Weather Map. And then lastly, I've got a spectrum analyzer and VU meter, which are probably some of the most difficult features to implement in any graphics library. And so I just used those as examples of, even with a fairly complex drawing task, it can fit right into this framework, and it's fairly extensible in that sense.
And notice that if you look at that screen, those are, each one of those things is represented. The date and time format, the weather format, and at the bottom of the screen, that spectrum analyzer thing.
Yep.
And then of course you've got this title at the top, which nobody understands, called Omnigon.
Yeah, so Omnigon is the name of the channel. I'm eventually going to elaborate further on that, but suffice to say, it's simply the brand of the channel, and it is how I identify with this channel. So the other important thing to understand about this project is that it is, I like to call it a framework. It is not a library that you import. This is a series of examples that you can quickly modify and adjust to get something closer to what you're looking for. It's not designed as a complete solution, and in fact, I have a feeling a lot of projects that want to use this are going to write their own, essentially, plugins to add on top of this to get exactly the stats they want. Some of the things that you might eventually build into this are like I'm listing here, a subscriber counter, resource monitor, basically any kind of data that you can think that you might want to send to this program and display should, in theory, be relatively easy to add with the way that I've built the functions here. So it's designed to be very extensible. It is not designed to be done really at any point. I We'll talk about it a little bit more later, but I eventually want to build this into a proper library so that you can have proper plugins for this toolkit. And then you can essentially just submit a plugin and have that attached to the programming. And then you can just add lines as necessary for whatever toolkit you may need.
Okay, on those items that you mentioned, subscriber counter, resource monitor, notification receiver,
Mm-hmm.
is there any reason why you picked out those items?
Because they are all text based. You can get really fancy with this, again, because processing is designed to be very user focused and very straightforward to program in. You can do fancier stuff. You could, in theory, have it display pictures, or you could have it, flash icons and certain things like that. The way that I've built it is primarily for text. So these things could very easily be updated by just telling processing to look out for some text or to fetch some text. And then you just add it as a line item to the display. Everything is arranged as a line. There isn't really a system built in here for moving all of the lines together. It's not really designed to have, an image go over the top of all of the lines at once. It's really made as a series of lines that you have common, simple to read, and again, because you're working on very low pixel density. For instance, the display that I'm using in my example videos is a 6 millimeter pitch, which are just absolutely massive pixels. You really can't read that unless you're really far away with very fine images. You have a very small workspace to work with. In fact, as to show just how small this is, I'm kind of hiding it right now. But if I pop this off to the side, you can see that this is a very, very small amount of data. There's very little information in this display. You really have to keep yourself focused on using pixel fonts. You have to keep yourself on low resolution. So while you can get fancier with it, it's difficult. And you run out of space quickly on a display with such a low resolution.
So let's ramp this up and say some really fancy high res gigantic display that is in Vegas. That's
Mm-hmm.
kind of what I'm thinking of when you look at one of those things and wonder what kind of software is behind those.
Those are typically, so that's actually a great point that you bring that up. Those displays typically have controller boards that will just blindly accept things like an HDMI connection or a VGA connection.
Right.
Whereas with the displays that we're working with a single panel of one of those displays. In fact, the one that I have is a modular panel that you would see at a concert venue or that you would see at, on a billboard. These are simply just a chunk of one of those billboards, but they don't have any controller hardware on them. They're quite dumb, in fact. You have to tell it everything. And so what I've attached to the Raspberry Pi in this case is it's essentially a miniature controller board that, again, the computer, the Raspberry Pi, is just telling the controller board, hey, here's my frame, and then that controller board translates that for the display. It also handles power delivery, which is, again, quite complicated when you're dealing with these really large pixels, because they need a lot more power than, say, a little tiny LCD display. So what it boils down to is those displays, like in Vegas or on a billboard, they're using far more complicated systems, and they require multiple controller boards per section, and then those all feed into some master controller that you just plug an HDMI cable into it, and then you send it whatever display you want. But that gets expensive because now you're running essentially a computer to drive your display, and then you need a computer to drive that computer, and now you're dealing with so many steps in your hardware stack that it's very easy to lose track or not understand what you're doing, and there's a reason you have to be a professional to really understand how to manipulate those displays. They're rather complex, and the point of this project is simplicity.
Good.
Mm-hmm. And that's a point as well, is that I've included as an example how my Python script works on the particular hardware that I'm using. But that's not the point of the project. The point of the project is in the sending side. Your receiver, you're probably going to write from scratch every single time you come to a new display. That's fairly expected with the way this is built. Um, but that's actually an advantage because that means that because your receiving code is so simplified, all it's doing is it's listening. It's not doing any processing. It doesn't have to keep the display in mind. It doesn't have to think about, what about, it doesn't have to keep any of that in mind. It's just, here's your display. I'm listening for pixels. And if I receive the pixels, I'll display them. And it doesn't have any intelligent sense on the receiving end. It's just a raw output of whatever it's receiving. Um, so yeah, the only other thing really to touch on the introduction here is the setup, which is a little bit. I'm trying to streamline some of this, and I'm open to suggestions. But right now, you can pull the first two primary libraries. There's two libraries here, minim and UDP. Minim is what's used for the audio visualizer that you're seeing here. And obviously the UDP library is what's being used to send the signal. And then the only other library that I'm using is the Open Weather Map library. And that's what allows the weather to be displayed. That one's a little more complicated because you have to go in and extract the zip file. But again, that's explained here in the actual setup instructions. And then you can provide your own pixel font. The pixel font that I just happen to use is one of my personal favorites, and I've provided a link to that as well on the setup page. Um, from there, it's just a matter of plugging in a couple of very simple variables. You'll need to get an Open Weather Map API key if you want your weather to be displayed. I've included a link for how to do that, as well as just you can put in your zip and country code. If you're outside of the US, they do have the ability to grab a location that way. Again, I've included the link to that page. By default, my ports are set in this project so that you don't have to adjust anything if you're using the same receiver, but I've left those variables in so that you can modify your ports if you need to send it to a different place. Uh,
What if some of the viewers have some questions for you? How can you facilitate that either through some kind of email or something to get
yeah,
back on things?
so primarily, YouTube comments are going to be the best way to start off. I may work on building an online community such as Discord, uh, and eventually work my way into having a bit more of a community set up for this. But for right now, I will be doing my best to answer any questions that I find in the YouTube comments and trying my best to, uh, you know, get to anybody and see to hopefully keep everybody in track and help anybody out that needs it. I did my best here though to keep it as simple as possible as far as the setup. What I will say ahead of time is I'll get into this later, but I actually am really rough on the details of the receiving end. That is the part that I struggled with on this project, and that is the part that I have the least experience in. But as far as how the project works on the processing end and running into issues there, I'd absolutely be able to dive in and help anybody that needs it and figure that out. So that's certainly something I'm willing to do.
Can you, if somebody else is modifying the project or creating another one,
Hmm.
can they create all this stuff on the sending side be and before they even actually have hardware on the receiving end?
Yes, so that that comes with a story. So when I originally set out to build this project, it was actually the display that inspired the project rather than a specific need for it. I saw these large pixel displays on the Adafruit site, and I really wanted to get one. But I have a bad habit in my past of simply getting a piece of hardware because I find it interesting and then realizing after the fact that I don't have the expertise to actually program it.
Oops.
Yeah, it's kind of an unfortunate cycle, but it does seem to happen more often than I'd like. In this particular case, I told myself before starting, I was like, I know how I'm going to handle this. I am going to I'm going to write the code for the display before I ever get started. I'm going to write all of my code so that I know exactly how it should look before I spend any money. And so this project took around 3 months of my time to get it to what you're seeing here. I took the time to figure out the spectrum analyzer and the weather map, the weather map API and all of this. This was a very intense, I say intense. 3 months is small in the world of a lot of programming projects, but this was 3 months where this was all I worked on because all I wanted to do was buy this relatively inexpensive display. I think the project total came out to something like $150. Well, I write all this and I'm like, cool, awesome. I'm going to go ahead and pick up this hardware and then all I have to do is figure out how to send the signal to the display, which I can't really test without the hardware. So I buy the hardware, I get it to my apartment, and I start following some of the Adafruit tutorials. And I'll even include a link to the Adafruit tutorial that before I bought the hardware, I assumed would be a very straightforward project to just give processing a space to send a signal to. Well, it turns out that that was not simple at all. And I had made the same mistake that I've made with many of my other hardware projects, which is I had the hardware and no way to send any signal to it. All of the demo projects I could get to work from Adafruit, and at the time, it was either completely rewrite this program from scratch in Python and run into all the same pitfalls that I was trying to avoid from the beginning, or give up. As sad as that sounds, this unfortunately sat in a corner for a couple of years. It was briefly used as the front display sign at one of my previous jobs, just because I was like, hey, I've got this thing sitting at home gathering dust. Like, I can at least make it display a simple scrolling image. Like, it's something. And so it got a little bit of use, but again, it was mostly a shelved project. Um, and then it was very recently that we had a very specific thing enter the tech space, and that was ChatGPT. It was ChatGPT that allowed me to finish the project. I've included a link to that as well. There were a few conversations I had with ChatGPT where I would go back and forth and I'd get close to a solution and I just had to get more and more and more precise with the problems that I was having. And it took a lot of tries. I would say it was about a month of going back and forth with ChatGPT and adjusting my questions and asking them in different ways. I've given the best of conversations provided in the link. I didn't want to have pages and pages of the questions where my thing didn't get answered. Um, but ultimately, it isn't easy to ask ChatGPT for what you want. But once you figure out what your actual problem is, once you have a fundamental understanding of what lines you want to connect in your project, if you can explain it well enough, ChatGPT can solve some very complicated problems. And in fact, if I did not have ChatGPT, there is a potential chance that I would have never solved this problem. I would have never
Now,
come
let
up
me
with a
be
way of
clear.
doing this.
The Chat GPT was on the Python side.
Correct. I there was a little section in the processing side that ChatGPT did walk me through how to add. It walked me through how to add the UDP send. Because I didn't know how that worked in processing, and I wasn't finding a ton of documentation for it. So I just asked ChatGPT. I was like, I have this processing project. I fed it my entire code base. I fed it my entire code base and I said, this is the hardware I have, this is the software I've written. How do I add the ability to send a UDP packet, and how do I receive in Python on the Raspberry Pi? And it got it wrong quite a few times at first, but I finally landed on it when I got a kind of half solution. It kind of worked. And I'll even show a video here of where it was broken, but I knew at that point that my display was receiving data. And at this point, I could, again, I kept feeding the code back into ChatGPT, code that it had written, but I explained what was wrong with it. I explained the actual output that I was getting and the issues that I was seeing in the output, and it was able to determine just through natural language what the actual symptoms were of the issue I was having, and it was able to fix those issues in its own code, and I got a very, very clean result out of it. Uh, Without that, again, I don't know that this project would have ever been completed.
Okay, I think the uh, person that's watching this for the first time, they're going to wonder, you went all the way to Chat GPT on the receiving side, and I think your main goal in this video is to talk about processing
Mm-hmm.
and the objects that can go to the screen, and then the receiver side is like a totally different episode
Yep,
of this journey.
absolutely. So we'll go ahead and this isn't going to be line for line explanation, but I did want to, kind of review the overall structure of how this program is built and where you can add things into this framework for yourself. So this is just going to be a rough overview of how it's structured, why I did certain things the way that I did, and again, how you can modify it to suit your own needs.
So
Um,
this is the, let's see, homebase.pde file,
mhm.
and this is where the whole thing starts. This contains all the information that shows up on the screen.
Yep.
Is that pretty much true?
Yeah. So it makes calls over to these other two functions, which we'll get into. But ultimately, this is where you're going to be doing most of your modification. This is where you're going to be. This is where you're going to be working with the display. If you want to add functionality, that's going to be mostly in the display class. But if you want to modify how it runs, that's going to be mostly in the home base file.
Okay, maybe you want to go through the the there has to be, I'm not that great at object oriented, but you've got
Mm-hmm.
to have a uh, main class somewhere, and then the other classes spin off of that. Am I on the right track there?
I That may be the way that Java works at a fundamental level, but that is again something that processing does very well is you do not need to start with a main class.
So it
As you can
hides
see
that from
here,
you.
yeah, as you can see here, we're just starting off by importing our libraries and building the display and setting things up. We don't have to do all of that class definition, and it just puts all that underneath the layers and it lets you start writing code. You don't have to have a really, really deep understanding of class structure and all of that, and your typesetting and everything like that. It's relatively simplified in comparison to base Java.
Okay, so where does the functional part actually start here? I see you're like any setup there, you've got the imports and so on, and then you're defining any program, you're going to define the data, and then you're going to start manipulating the data somehow.
Yep. So up here, like you said, this is all of our library imports. This is where we're defining Open Weather Map right here. We're just giving it some basic information. We're setting up the boot logo, setting up the date, giving it a frame rate, setting up the visualizer, setting up the UDP frames, setting up the. So this is key. This right here defines our lines themselves. This is our display object. And the way that this is working will not get too much into the weeds here, but the important thing is we're creating an empty array that's going to hold our line objects. And then lastly, we've got a little bit of notification setup, and then this is where the functional part starts, this void
Okay.
setup.
If you can back up just a little bit on the array list,
Yeah.
what's the syntax there of that array list with the less than, greater than around the display? What's Can you explain that a little bit?
Yeah, so this object right here. So we're defining we need to create a place where multiple lines are held in a single spot because that makes it way easier to manage. When you want to, for instance, not draw any of the lines to the display, you don't want to have to go to each line one at a time and turn them off. You want to be able to iterate through that list and turn them off all at once and not hard code. So what this is we're creating a list called lines, and then specifically it is an array list. So Java gets a little bit complex, but what we're saying is we want to create a list of objects that are of the type display, and that is the display class. So we're creating an object. It's technically a display object.
Okay.
If I was smarter, I would have called this a line object, but I'm not smarter, so I didn't. That may get updated in a future version, but ultimately this
Hindsight is 2020.
exactly. So yeah, the technically this is more of a line, but you would have an individual line object, in this case a display object, and we're storing however many of those objects that we will define later into a new list. We're saying this is the object type, an array list of display objects, and then we're saying I need an empty array to start with. You have to start with something, so you just start with an empty array. And that's what this new part.
Array list is a keyword.
Yes, that is array list is essentially a list of objects. It's fancier than just a regular list
Right.
because you don't have to call out that you're just making a regular list. This is like a fancy list because it can hold whole objects rather than just variables.
Okay. And the the less than, greater than sign on either side of display, that's the way you define it. I mean, that's a standard way that you that's that's the processing uh in parentheses Java syntax.
Yeah.
Okay.
So then we get into the functional part. This is where we're getting everything prepared. Now, this, if you just ran the setup function, nothing would be on the display. This is not updating the display in this setup function. This is just to go, okay, now that we have a bunch of static variables assigned, now we actually need to go through and get it going. Like we need to start the motor. This is all telling you the size of the motor. Now we need to actually, run it. So we start by setting up our size. We give it our frame rate. We blank out the background. This is important. We'll get back into this later. But this is your color mode, so this lets us work in the hue saturation value space rather than red, green, blue. We're creating our font here. We're getting our text defined. Just lots of housekeeping stuff, right? Like you're not really doing anything here. You're just going, okay, now that we know what to prepare, let's go ahead and roll it all into a pile and get it going.
Those are you're initializing certain pieces there.
Yep. So right here we're initializing the boot logo. We're initializing the audio. We're this is that bit that I mentioned earlier where before it was an empty array list, but now I'm doing the math. I'm checking the height of the display against the height of the text, and I'm saying, hey, how many lines do you have? You know, this is a 32 pixel tall display. We're working with an 8 pixel tall font. Let's go ahead and divide that out for you. Okay, that's how many lines you can fit on your display. Good to go. So you don't have to do the hard work of like, oh, let me define the number of lines, even though I already defined my height of my text. Like, you have the two variables already defined. You don't need to do that yourself. You can also, this is also where you can define defaults. So if you want all of your lines to behave differently than the default, you could define it here, and then you don't have to set it for each and every single individual line. You just lay out your defaults, and then you go, all the lines are going to get these properties. Then we are creating our clock. This is where we're actually grabbing the clock time as well as the weather. The update weather command is further down. We'll take a quick look at that later. And then this is the important bit. This is where you actually tell it what is going to show up on each line of the display. Because right now it's all empty. So
Okay, so the index there, the 0, 1, 2, 3, those are the different physical lines. Is that correct or
yep.
something?
And we can see that in the little virtual display that I have right here. So line 0, because of course we index from 0 in programming space, unless you're in Lua and you're weird. The Omnigon that you're seeing up at the top, just as it says, rainbow equals true. I made these very simple functions. We've got a clock. There's some things I could do some code cleanup like line mode. You'll see that in the display here. The line mode is a little rough. You can get better naming schemes for this. I have not updated that yet. But then we've got the mode of scrolling. Again, this is defined in the... This is a little unorganized in places. This is a little rough. Again, this is a framework, not so much a completed project. But like here you can see scrolling forced on, scrolling forced off, scroll once, things like that. Then we've got, we can very quickly define colors here. So by default, if you only give it one number, it's just going to be a 0 to 1 value for black to white. But then you can define more colors by using that hue, saturation, and value. So you could do like, if you wanted to get red, you would say hue of 1, or hue of 0, saturation of 1, value of 1. So you could say 0, 1, 1, and that would define red. Line mode 3 is just weather, and then line mode 1 is a visualizer. And then we've got two different visualizers. We've got a spectrum analyzer, which is the one that you're seeing here. And then the VU meter, which is the alternative, is a little bit simpler. It's just a bar graph essentially of how loud whatever sound it's receiving. But obviously to show off, I wanted to show off the fancier effect. Then we've got so this hue cycles function. This is kind of neat. If you notice, The colors on the spectrum analyzer are constantly rotating. And if you set this to a value of 1, it will go all the way from red through the entire rainbow back to red. But I wanted to, make it a little more subtle, so I just dragged it out and did half of that. So it goes red to halfway through the rainbow, and then as it rotates, you'll eventually make your way back to red. So
Is
just
this all in the,
little
are we still in
touches.
the setup?
Yeah,
We're
this is
still in the
all still
setup?
in
Okay.
setup. Yeah, this is all prep work. So this is just telling it what each line is going to be. And then lastly, we just tell it, hey, get ready. You're going to be sending UDP packets pretty soon. Go ahead and define that. Then you're done with the setup. So that
So
is
the
all
setup,
initializer.
once this thing all starts up,
Mm-hmm.
the setup just runs and never returns again. Then you go to draw.
Yep. So this runs
Wow,
once.
this is pretty clean. I
Yeah.
mean, this doesn't have the normal. Okay, I got you.
Yeah. So then we get into the draw. So the draw function runs every single frame. This runs 60 times a second with the way this program is set up.
And as we're looking at the screen, so draw is running as it's doing it, as you see what's happening.
Exactly.
It's all so draw is that's the functional loop or whatever you want to call it.
Mm-hmm. So that basically tells it this is what it's checking for every single time, and if this doesn't run, the display doesn't display. So the very first thing I do on every single frame is grab the fresh time, because if you don't do that, your time will just not update. That was weirdly confusing at first for me, but yeah, it makes perfect sense. Then I kind of do a little bit of a safeguard for the user. One thing that can happen with, especially with free API keys like those from Open Weather Map, is if you just spam them and you're trying to grab the weather 60 times a second, they're just going to cut you off. They're going to say, "Whoa, whoa, whoa, whoa. You're bogging down our server. You're asking way too much. You don't need to know the weather on a second by second basis. Calm down there, hotshot." So I built in a little function that basically takes your. It's a little bit of a loose function, but it basically just says, hey, probably shouldn't be pulling a fresh weather information every 5 seconds. So I limited it to 5 minutes as a hard coded value here. You can define, I think it's up here, you can define your own update interval. But even if you set this to like 0, you're not gonna. It's gonna prevent you from getting yourself into trouble. Notice that it even mentions that here: minimum 5 minutes, recommended 10 to 20. Because yeah, again, you don't want to spam their servers, and in fact, the code will run incredibly slow if you do that because it has to wait for Open Weather Map to respond, and so it'll just drag on top of completely ruining performance. It'll lock out that API key, all sorts of stuff. So I just prevent that from happening here.
Is
Um,
is just because, we're getting into lots of details.
mhm.
Is the draw once you do setup and then draw, it stays in draw indefinitely?
Yes,
So is this it for the homebase.pde file?
there's a little bit more down here. It looks like a lot, but it's not actually. And in fact, the draw function isn't that long. You're looking at all of it right here. The
Okay.
draw function is shorter than the setup. So then we just clear out the frame. We say if the boot variable is true, so you'll actually see that's one of the things that gets defined on boot. You're saying, hey, if the boot up is true, then display the boot logo. One of the things I wanted to be able to do for demonstration was to be able to force the boot logo. So if you just press the B key, you can actually force it to display. So that's sort of what the boot sequence looks like. And it also has that little fancy animation where it pushes the text back up to the top. And yeah, this is essentially all the boot function does. It just runs that boot logo
Then
from left to right.
good old UDP send at the end of draw.
Yep. So, and yeah, this is just all of this extra code here. So this is all that is rendering the lines. This is it. This is right now what we're looking at on this display at the top. This is all of the code. This is it. Everything else happens under the display class.
Which makes sense. You've got X number of lines, and you do the for loop on each one of those lines.
Yep. So
Now, wait, when you complete those lines, then how does it start over again?
then it sends the UDP signal, and then the in processing the draw function is treated as a loop. It's treated
Oh,
as your
okay.
loop
So that's
function.
even though there's not a while or a for or anything else there, it just draw becomes a loop. Just
Mm-hmm.
it just becomes a loop. Now,
It's
so
just
the
another
other
one of those things
functions,
that's it's another one of those things that's assumed because you're working in a graphics library, you're gonna want to update something every frame.
then uh, then as you go down here for these other parts of the code,
Mm-hmm.
these are functions that are called within draw.
Yeah, so you'll see the update weather. That's where we're calling it
Yep.
here every maximum 5 minutes. This key pressed, this is another key function built in to processing. It's always listening for your keyboard, and whenever you press a key, it runs this function for you. So we check and we see, okay, you can press escape or Q to quit. You can press S to reinitialize audio output. So in Windows, especially when you change the default microphone, it doesn't update for whatever applications were already hooked into the old microphone. So this just lets you hit S for sound to reinitialize the sound. Or I guess maybe it's S for source. I don't remember which one I did.
So
uh,
when it's running, for instance, when it's running to the display, you can hit certain keys and change the display.
mhm.
Okay.
Yep. And this may be expanded on in the future as well. This is very much a place that has room for expansion. So if you wanted to, for instance, I'm in a tabletop D&D group that I play every Wednesday, and one of the ideas I had is it would be fun to have little animations that could play when you press a key on a little controller so that you have like, oh, somebody you got to hit, you hit a button and it shows a little animation of shooting an arrow or or making something explode. So it you can definitely get fancy with it, and the key pressed function is where you can definitely expand. In fact, you'll see I have a little example of like, here's an idea. This is nowhere near completed, and this was just a like, hey, I want to make sure that this functionality works. I made a fun little tester where if you just hit the N key, it could show what a notification might look like. And the only thing I could come up with is to say bomb diggity, because why not? Uh, but yeah, you
Hmm.
can just have a little you can have a little notification pop up, and it's
Diggity, huh? I
yeah.
won't even ask you where you got that.
I mean, I don't know. It's just one of those
Yeah,
things.
that's what I mean. Keep moving.
So, lastly, this is the part that the AI wrote. This is the part that I did not know how to write on my own. And you'll, in fact, see this exact code in my conversations with ChatGPT. But it did a great job of explaining it. Now that I see it written out, like I can piece together what it's doing and how it's doing it. And this just kind of says, okay, so we're going to take these parts of the byte. It's essentially capturing the frame.
Ah, bit manipulation.
It
Ha
absolutely
ha, you don't
is.
like that. You don't like
So
your bit
I
manipulation.
don't. I'm so bad at it. uh,
Yep, shift 16, shift 8.
yep.
Ah, yeah, shift 24.
And
Mask it
so
with an FF.
the way that it does it is it grabs the full frame, and then it takes every single pixel in that frame and breaks it down into an individual byte. And then for each and every single one of those bytes, it rearranges the pixels to match whatever your receiving display is. So This could be, depending on your display, this may need to be adjusted. Depending on how your receiver is written. Now, ideally, you write your receiver to match the order of pixels, which the way that this is written out, and again, you can see this in the logs, but essentially, the way that by default the pixels get arranged in processing is ARGB, meaning you have 8 bits of alpha, 8 bits of red, 8 bits of green, 8 bits of blue. The receiving end was RGB-A, which was really frustrating and why I was getting all sorts of broken color issues. I was getting all sorts of like weird graphical glitches that just didn't quite make sense, stuff like that. And
Of all the code that you have here, this makes the most sense to me of all of it.
because you're used to dealing with like,
Yep.
you're
Bit
used to working
shifting is
bit by
it
bit.
very normal.
Yep.
Okay.
And this is where the efficient stuff comes in. This is where you want it to be really, really fast because you don't want to waste time rearranging pixels every frame because this does have to get called every single frame. So you need this to be very, very efficient. And that's another point that I wanted to actually circle back on. You talked earlier about those very large pixel displays. This would be horrendously inefficient for those. This does not scale large. This scales in functionality. I would not say that this is a great framework to use for a big, big display. Like 256 by 512, yeah, that's about the largest I'd use it. Like I'd use, like this with chunky pixels, as I like to call them. This is good for showing off like the very clear, distinct pixels. This isn't great for a 1080p display. Like it would just chug through that because every single pixel is having to be translated into another series of bits. Not very efficient. And then all you do is you
Okay.
just
I think
send that
this
rearranged.
is if the processing file is probably that's a enough for the digestibility of this at this time. I to
Mhm.
move beyond what we've done now seems like we need some absorb time. Don't you believe that?
Yeah, I think I can agree with that. And ultimately the display and notification classes, while you can get into the nitty gritty of these, this isn't really what shows off the project. This is all just functions
No.
at this point. This
Right.
is all just defining defaults, defining how these things get drawn to the screen, which there isn't really that much to say.
Yeah,
We draw clock to the
the
screen, we
details of
draw
the
text to the
objects,
screen, like yeah.
the details of the objects are kind of like uh, things that you import to a project.
Mm-hmm.
If you like the different objects that are in here, you just leave them alone. If you don't like them, then you get in there and modify them.
Yep, exactly. So and I there isn't this is something that I could probably come back here and clean up. Like there isn't very much there's no commenting on my scrolling code, but it's all relatively self-explanatory. Like it's pretty simple. It moves things from left to right or from right to left.
Well,
It
if you name your variables correctly, it's becomes self-commenting.
mm-hmm. And that's where like the like the VU meter and the FFT spectrum analyzer, like yeah, this you can definitely dig in and see how I built this and like understand all the math here. Do you need to? Do you like this effect? Okay, it's good where it is. Like there's not really much to mess with here. This is the extensible part of the program. This is the part where if you're wanting to add something, you know what you want to add and you know where to look and you know what to program. This is all the stuff that's unique to this project and really kind of sets it apart. It gives you a quick way to just draw some lines of text to your screen, add some simple effects to them, and move on with your day. If you want, like, For example, like a restaurant display where you have a little, daily special thing that just kind of scrolls by, or maybe you have, like I was saying, like a D&D thing that shows everybody's current hit points, or any number of things. There's lots of different things. You know what you want to display on this project. What you don't know is how to use it until you watch the videos. So I think we're at a really good point here where we can kind of wrap it up and ultimately say that this at this point is open to your interpretation, and you can change whatever you need to make it fit your project.
Okay, let's hear those. Let's hear those YouTube comments. We
Yeah,
need those. We
absolutely.
need those, and that's what we wanted. That's what we wrote. Why we collaborated on this, so we can find out what you're looking for and what your projects are, and I can decipher what you need, and then Austin can help you get the technical details taken care of.
Absolutely. I would absolutely love to hear what kind of projects people are making, hear what kind of struggles you're running into, and if I can help with that. And the project is obviously on GitHub, so you're welcome to fork this project and add your own projects on top of it, modify it. I encourage it. So feel free to use this code in any of your projects. I have no licensing attached. I'm not going to track you down for using my code. I much prefer that you use it and just get what you want out of the project. That's what I want more than anything else on here. So I think that pretty well wraps it up.
I Do we have any closing music or anything? Any nice
Um,
little credits to roll or
I guess we're about to.
directed by?
I guess we're about to find out.
I guess so.
All right. Thank you for joining again, and we will see you hopefully within the next month.